Okay, welcome to today's Kitchen Science. I'm Mrs. Pudney and I'm going to take you through some really simple physics demonstrations that you can do at home. And I think particularly if you've got a younger brother or sister, you can definitely freak them out with these ones. So first of all, really simple one. I've got two books. What else would I choose but physics books? I've got two books and I am interleaving the pages. Now, I'm doing that sort of every couple of pages, so it takes a little while to set this one up, hence I started earlier this lunchtime, and I'm just interleaving the pages. So I've now got two books that are completely interwoven together, and the challenge is to pull them apart, okay? The challenge is to hold both ends and pull them apart. And as you can see, Pudney can't do it. Oh, and my challenge to you is, can you do it? And even better, if you give it to a younger sibling or even an older sibling and really annoy them, then they can't pull it apart. Because by interleaving so many pages, what we've done is we've created a really big force of friction. Friction acts against the direction of motion. So as I'm trying to pull them apart, friction is pulling them back in the other direction. We've got forces acting against each other and I can't pull it apart. And I'm actually trying really hard here and I definitely can't pull those books apart. If you can do it and show me a video, brilliant, send me a video. Okay, next really simple one. I've got a beaker of about 2/3 filled with water. Okay, and what I'm going to do is I'm going to take a little bit of milk, all right, just a little bit, if you're at home and you don't have a pipette, obviously, probably about a teaspoon, okay, about a teaspoon or half a teaspoon of milk. Okay, I'm going to put that into my water and I'm going to give it a mix. So now I've got a mixture of water and milk and it looks a bit, ugh. Okay, so I've got a white cloudy mixture of water and milk. And you'll see this much better when you do it at home. What you need to get is a torch. And what I want you to observe is the colour of the water-milk mixture in different lights at different angles, okay? So at the moment, it's slightly white. You might be able to even see a slightly blue glow. When you pass the light through the water at different angles, you can get different colours. You're probably going to struggle seeing that on the video, so this is one to try at home. Email me with what colours you found. Try it from top, try it through, try it from the bottom. Try shining the light through the bottom of the milk and see what different colours you get. And email me with what you managed to get, okay? That's that one. And the third one, you need a drinks can. Other drinks are available. You need a fizzy drinks can. And you need a fizzy drinks can because you need a can that has that rim at the bottom. Okay? And I'm going to take about 100 millilitres of water. Okay, so it's not very much water. And I'm going to pour it into the can. And I'm a physicist, so my pouring isn't brilliant. So I might have a few spills. But there you go, I got most of the water into the can. Then what I want you to do, put it on your table and then tip it until the can balances on that rim, okay? Get it to balance on the rim at the bottom. So I've now got this can balanced at an angle, which is weird in itself. But what you can do, if you're very gentle, it might take me a few times to get it going. If you give it a gentle push, you can get it to go around in circles. Let me see if I can get it angled again. Angled again. Here we go. Give it a gentle push, and you can get it going round and round in circles. It's what we call a pirouetting can. And the reason it does that is all because of centre of mass. We've been doing this with year 10 and also with year 12, but it's really simple. When things balance, they balance because their centre of mass acts through their base. If I take this torch, its centre of mass is probably sort of here-ish, and it's acting through the base. If I tip my torch too far, the centre of mass now isn't acting in the base, and it falls over. By putting the water in the can, water's a fluid, it moves around, the sausage around, which means that it moves to move the centre of mass with the can. So as it moves, the centre of mass of the can actually moves with the can. So it's very easy to get it to balance on its rim and move round and round and round until it falls back to the centre. Have a go at these experiments. Send me some photos or videos if you manage to do them all. I'd be particularly interested to see if anyone manages to fool their sibling with the bookworm. Send me your stuff to ann.pudney@surbitonhigh.com, and I'm sure I can send out some merits and commendations. Have a great day, everyone. If you're in the sixth form, you're joining us tonight for the sixth form debate. Otherwise, see you tomorrow at 1 p.m. We're going to do a biology dissection for you. See you tomorrow. Bye, everyone.